So we're going to talk about a project that we're actually still currently working on with the City of Moline, and it is based out of their North Slope Wastewater Treatment Plant. Back at the very beginning of 2020, they put out an RFQ for engineering services for a study to determine the best approach to dewatering of their biosolids at the North Slope plant. And yay, CMT was selected for that. So we were very happy to get to work with the city. The scope as it was originally written was to evaluate methods for biosolids dewatering, and then what they wanted was a cost of ownership for each of the methods that we looked at. One unique feature that you may or may not know about if you're from the Moline area is that the North Slope Wastewater Plant actually receives the lime sludge blowdown from the city's water treatment plant, and that actually goes into the sewer and makes its way to the plant. So as a result of that, they get some heavy grit and end up having an extremely thick solid, sometimes dewatered up to 50% dry weight. So the North Slope plant at Moline, the plant capacity is 15 million gallons a day. The original plant was built in 1966 and has had numerous upgrades since then. It's a conventional activated sludge plant. And as far as biosolids, they do, what's shown here is a belt filter press and then a belt conveyor that takes the biosolids out. And I forget because I've been doing this for over 25 years, but basically biosolids are the solid product from the wastewater treatment process. Everything that settles out in the primary clarifiers, secondary clarifiers is all taken together, and then it's treated, and ultimately before you can either land apply it or handle it wet or dry. Handling it dry gets rid of a lot of the water, so a lot of places prefer to dewater their solids before they either land apply or landfill them. So their current operation, as I said, this is a picture of a belt filter press, and basically how it operates is it's got a perforated belt. The biosolids, which are probably 8 to 10% solids when they go across it, the water drains down and goes down into the sump that you see, and then the dry biosolids come off the top and then fall onto the belt conveyor that's in front of you on this picture, and then that goes on out. Where it ends up at is it's dumped outside into a pile, and then the plant staff running heavy equipment actually manually loads the trucks, and then these biosolids are taken to the landfill. So it's a fairly labor-intensive process, and we'll get more detail as we go. The current process, for any of you out there that actually are in the wastewater field and have dealt with belt filter presses, are not going to be surprised at these likes and dislikes. The thing they like about them is they process a very large volume of solids in a short period of time. It does do a good job of dewatering the biosolids, gets it down to typically around a 22 to 26% solid on a typical municipal sludge, and they only have to run it twice a week. The dislikes, the filter press requires a lot of attention. Somebody kind of has to be there keeping an eye on it to make sure that all's going well. The startup and shutdown are time consuming. The conveyor, as you can guess, is pretty messy. As the stuff falls off, since it's not enclosed, biosolids can fall onto the floor. Belt wear is an issue here because of the lime grit, and having to replace that every so often becomes a costly venture. And then the dry handling is labor intensive, having to move it independently with the end loader and putting it into the trucks. So once we got the project, it was time to sit down and do a kickoff meeting. And something that CMT and myself find very important is we like to define the owner's expectations. Just because we know this and we do something, we don't know what it is that is their driving force for their decision making. So we sat down and talked. First, they would like to, if at all possible, reduce the labor to dewater and haul the biosolids. Again, as we discussed previously, the belt filter press is very time consuming. So is there a way to automate the process of dewatering the biosolids? Is there a way to eliminate that manual handling of the dry sludge? And is there a way to reduce the labor at the starting and stopping processes? So basically cutting down on the overhead costs of getting the biosolids dewatered. Next, and again, everybody likes a process that's easy to operate and also can be maintained pretty easily, and many times maintained by in-house staff. So can the process run unattended? Is the general maintenance on this piece of equipment minor, or does it have to have a specialty person come in to do the maintenance? Does the process have redundancy? What happens if you have a unit of equipment that's out of operation or something that fails? And last but not least, annual maintenance. Can those kind of things be handled in-house, or do you have to call in specialty? More of the critical criteria for the city. Now this one's an interesting one because it's the calendar. So in the past, they had already looked at rebuilding the belt filter presses, but it hadn't moved forward. Then there was a change in the operator at the plant, and the new operator thought, maybe we want to look at something different. Do we really want to go back with the same technology and have the same problems? So it was, can this existing equipment be rehabilitated? And second, by doing the study and then going to a design, is there going to be time to get this process done before the existing equipment actually fails? The belt on the conveyor has been slipping, and when it slips and when it expands, it can come off the tracks. All of these things are very time consuming and a mess to clean up. We also wanted to look at chemical costs, because really what you want to get at is the total life cycle cost to run the equipment. And that includes polymer addition, the energy it takes to run the process, and then the labor it takes for operation and maintenance. And then mine and Maddie's most fun one is constructability. What level of modifications are required within the existing footprint? Because they have a dewatering process. Can we go back in and either rebuild what we have or put in something different within that same footprint and without having to allow demolition? Can the construction be accomplished and still maintain operation with a minimal downtime? And last, how much of that existing infrastructure can we actually reuse to accomplish our final result? Because reusing of any infrastructure is obviously going to be a cost savings in the long run. Options to consider. We sat down and had a long conversation about all the options for sludge dewatering. First option, obviously, is rehabilitate what you already have, which, again, needs a complete rebuild, not just a belt. Everything needs to be overhauled and replaced. Look at another technology called a screw press. We'll show you some pictures of that later. And last but not least, a centrifuge. So the difference between a screw press and a centrifuge, a screw press actually, it has a screw inside of it, and it turns very slowly, and it pushes the water out of the biosolid. And so the biosolid works its way up the screw or down the screw, and then it discharges. And they rotate maybe like Maddie, how many revolutions per minute? Do you remember?
I think it's like 0.25.
Very, very
like
slow. So then on the centrifuge, on the opposite, it spins very, very fast, and it throws the solids outside and removes the water that way. And it runs at, and Maddie can correct me, like 30,000 RPM. So you've kind of got two alternatives that are at opposite ends of the spectrum, but both do a great job of dewatering the biosolids. Lastly, after we got the project and during the kickoff meeting, someone with the city asked us if we could look at their existing system and based on this rebuild, if we could recommend any modifications to the existing operations that might be beneficial to them in the long term. So we also took a look at that. Before we even got started, the city was on top of it, and they had been looking at some options, and they actually already had their first pilot done on a screw press there at the plant because they wanted to confirm whether that equipment was capable of working with this really gritty, heavy, thick sludge. So they had a head start on the whole process. Going back, why did they do pilot studies? Well, this is that unique sludge. With that line from the water treatment plant, it actually improves the settleability of the sludge during the thickening process, and they have been known to actually be pushing 20% cake solids to the presses and coming off around 50. So additional grit was very abrasive in this whole process. So you're moving a very thick solid that's got a lot of grit and wear and can tend to wear parts. So we want to make sure that this is a good fit for this technology. The screw presses were originally designed for use in the pulp and paper industry and have been gaining popularity in the wastewater side. So kind of a little bit of a new technology, in particular when you have a slightly unique biosolid. They do tend to do, this sludge actually it dewaters very easily because of the coagulants that are in it, and ends up making that thick biosolid. Who was piloted? FKC, Huber, and Schwing Bioset. Every system was able to achieve between 49 and 61% cake solids. And in these photos, that's what that is. It's hard to believe that there's still that much water in it, but it looks dry, like potting soil ready to go out. The polymer usage, which is always a critical factor because that drives the cost of the process up. Polymer usage was between 6 and 23 pounds of active polymer per dry ton solid. And we used that as part of our evaluation of the overall costs that were put into the study. So when we got to our alternatives and to our final costs, replacing the existing belt filter press and conveyor. So we came up with we looked at a belt press, centrifuge, and screw press, and came up with total present worth costs for each of those options. And as you can see in this table, the annual O&M was a true driver in the overall cost and cost savings of working with each of these. So the City of Moline decided to go with the screw press. This is an example of a slide of the dewatering capability of one of the pilot presses. They were getting between 56 and 59% cake solids, which is like dirt. You can move very easily. So the pilot test results all came in very well. They have a long equipment life. The maintenance requirements are pretty simple. And this particular piece of equipment can actually operate 24/7 through SCADA not being manned. Then we got to, if we're going to do this, what does the future look like for the way they actually handle and process their biosolids now? So as a result of selecting the screw press, which can run unmanned, they could actually look at changing the way they decant or thicken the sludge. Their current operation is they pump the biosolids to a sludge storage tank, and then they allow that to settle over time, and they pump the water off of the top of the tank as the sludge settles, which we call decant. So that decant then is directed back to the head of the plant for retreatment. So in this scenario where they are decanting in large volumes, they pump it down like once a day, and then they slug load all of the high nutrients that are in that water to the head of the plant. If we went to the screw press, it would run slowly 24/7, and that filtrate would come through at that slower pace and equalize over the 24-hour period instead of coming in all at once in a slug load, which would not only help current operation, but will help future operation as the nutrient requirements get more stringent for removal. Now we get to, what about the schedule? What are our options for moving this project forward? We've done our study, made our selection, and the City of Moline has commented that they're really concerned with how much longer this equipment's going to last. And they had the money budgeted to do the project, so there was no need for outside financing. Well, we looked at a lot of options, and before we go forward, this kind of equipment has in the past taken maybe 5 to 6 months for delivery, and now is taking upwards of 6 to 7 months for delivery. So what are the choices for how to get this project done from start to finish and do it in the most effective timeline possible? We look design bid build. That's the stereotypical way of doing it. Get a lot of quality, maintain your quality in the project. We're always checking back in with the owner, making sure that the design is what they wanted, but it does have the longest schedule. Design build, well, that'll shorten the schedule, but we're all working together and running towards this schedule. So maybe it works and maybe it doesn't. Equipment procurement, bid installation, we looked at that because we had done that once before. Basically, the owner procures the equipment, And then while the equipment's being manufactured, the engineer's doing the design of the final bid package. Then we put the bid package out, and the contractor's getting selected right before the product is delivered to the site. So the client, the City of Moline, decided that the equipment procurement bid installation project was what they wanted. So the equipment procurement process, how does that work if you haven't done it before? Basically, the engineer, us, and Maddie was involved in this, worked directly with the manufacturers to configure a layout within the existing building that's going to meet all the owner's unique needs. And we basically went with 4 manufacturers. We did 5: FKC, Huber, Schwing Bioset, BDP, and Ishigaki. Ishigaki decided not to bid it because of the thickness of the sludge. So we were working to make sure that we had a system that would lay out that all of those could bid competitively on. And then I'm going to turn it over to Maddie to talk about the detailed layout and the costs.
Yeah, so when we discovered we were going to do the procurement process, we thought it would be very important to work closely with the manufacturer because of the unique conditions that we have. You know, the client wants complete redundancy in the system. We have an existing building we want to work around, and there's this thick lime sludge. So what we wanted to do is really have open communication with the manufacturer, so we knew exactly what they were going to give us, and we knew that, you know, the bids that were going to come in were going to fit with our space. And something that kind of came with that was the manufacturer provided several layouts and cost estimates that we then later evaluated based on our client's needs. So this photo here is actually the exhibit that we included in our procurement documents. So just to kind of explain what's going on here, we have the 2 proposed screw presses there, those rectangles. And then we have the 2 incline conveyors that are kind of going to the right there. We have 2 of them because there was a really big emphasis on redundancy, because if there's a single point of failure, you know, the client didn't want to have to deal with that, you know, in a timely manner. So they always gave us this example about Christmas Eve. You know, something fails on Christmas Eve, then they want a backup so they don't have to come into work. So that's why those 2 conveyors are there. And those conveyors lead to the other conveyor that's going up and down on your screen. And that one is actually going to be controlled by the ultrasonic level sensors in order to convey the solids to their respective piles. So what's going to happen is, you know, the first chute will be open, the solids will drop down into their pile, and then once that pile gets to a certain height, it will automatically shift to the next chute so the next pile can be started. There's also a conveyor that does go outside of the building just in case they needed to drop the solids outside for any reason. So those dotted lines that you see on there, can you go back really quick?
Yeah.
So those are that's the left existing belt press and the existing conveyor. And something that's really unique about this is that they want to keep that left belt press running and the existing conveyor running while we construct the right screw press. So what's going to happen is that the right belt press is going to get demoed, and then the right screw press is going to get constructed, all while that existing equipment is still going. And then once that right screw press is constructed, then we'll turn that one on and then demo the left. And really, this is just so there isn't any point of total shutdown for the operators. And again, this is the exhibit that was included in our procurement documents, and this is the exhibit that all the manufacturers had to make bids on. So for the specifications, multiple manufacturers were sourced and compared to level the playing field. So we quickly realized that the systems of all the manufacturers really widely differed, and we really couldn't formulate one spec that would be able to fit them all. So what we did was we created 4 specific manufacturer-specific specs So everyone would be included in our procurement documents. And at this point, it's important to note that the manufacturers and the engineers actually have contributed a lot already to the procurement in the project as a whole. We've already gathered a lot of information and we've done a lot of work to, know the layout, know the equipment that we're going to use. So this is really going to help streamline the design process because now we can focus on things like sequencing during our design phase. So overall, our procurement documents consisted of your standard front-end documents and then those 4 separate manufacturer specs that I'd mentioned. But at the end, we did have a polymer feed system alternate. So Moline does have an existing polymer system that could potentially work with the new screw presses, but they need to be updated. Basically, what's going on is that the pumps are just too big because the screw press requires much less polymer than the existing belt presses do. So those pumps would have to be changed right off the bat. So what we decided to do was get the alternate just to see how much it would potentially cost to revamp the whole polymer system and see if that was a possibility for the city.
Perfect. So the selection process is not necessarily based on the lowest equipment cost. Since we're looking at annual operating cost, we're looking at the chemical usage and the maintenance requirements. And per our procurement documents, each manufacturer was required to provide those costs to us as part of that overall package. So when the city was getting ready to make a decision, they had everything put together and they knew that long-term cost. So things to keep in mind on the schedule were government requirements for approval. We had to follow along with the council meeting schedule, make sure we had the number of readings required, getting all of this approved. Then there comes the shop drawing schedule and approval, which after it is approved and the PO is issued, then the manufacturer can start preparing the shop drawings and submit them. But we also have like these new and exciting factors that have come into play since COVID, which is supply chain issues and issues with manufacturing and delivery to worry about to maintain our schedule and keep everything operational until we get live. So where are they now, or where are we now? Procurement is complete. The City of Moline selected the FKC dewatering system, and that system actually includes the screw press, the flocculation tank, and mixer, the sludge feed pumps, the conveyor. And the interesting thing of doing it this way is all of those controls for all those systems are all combined from a single source of responsibility because everything ties back together. So that keeps it as sole source responsibility on the controls, which is a good thing. The selected bid cost for the equipment was a little over $1.1 million. And the shop drawings were reviewed in February, and this last week we actually got those turned back around to the manufacturer, and Maddie had a meeting with them, and we are anticipating a September delivery date, crossing our fingers with the way things go. So CMT is designing the bid package based on those approved shop drawings, and we'll be going out to bid in June with an expected notice to proceed in August of 2022. So I'm going to let Maddie talk a little bit about some of the unique things that doing the procurement and then the design do as far as allowing you to really focus in on your design based on what you know you're going to get.
Yeah, so the system that you see here is what was submitted to us via the shop drawing, and then we put that into our existing building section. And there's just some unique things about this building that are important to point out. So those T-beams in the ceiling and then the existing drainage channels in the floor. So actually at that highest point of the vertical conveyor, it's only about 4 inches from the bottom of that beam, which is which is a pretty tight space to work in. Just from seeing this exhibit, we decided that a few adjustments and tweaks might need to be made. So this is where the procurement, open communication with the manufacturer really comes in handy, because just a couple days ago, we had a meeting with the manufacturer and, we discussed some tweaks like these supports here underneath that incline conveyor, there's only about 1.5 feet from that tallest support to the wall. And the city really wants some more space there just for walking and working. So those supports and those cross braces are going to be tweaked a little bit. It was also discussed that it was really important to have 6 feet in between the two screw presses because there's a motor there that at some point you're going to have to perform some maintenance on. So we just want to make sure that there's enough space in between to do that. So it's been really great just talking with the manufacturer and the client and just having that collaboration that comes along with the procurement so we can make these adjustments. So this is the floor plan that we're kind of working with right now. This is kind of the up-to-date thing that we've got going on. There is a slight change from that procurement exhibit. The presses are just slightly staggered. And this is just to make room for those double incline conveyors. So since we have this layout and we know exactly what's going to go into the room, really we've been focusing a lot on sequencing and constructability at this point. So we've really been focusing on how are we going to install that right screw press while the left belt press is still in operation. But really this all starts with how we're going to get the equipment into the building. We know that we can take apart the existing belt presses in pieces and take them out in pieces, which really isn't a big deal, but we really needed to find out, are these screw presses going to come in one piece? Are the motors going to be separate? And stuff like that. There is a knockout panel on that south wall there that we have discovered from existing plans, but even with the knockout panel, getting the screw press in the building while the existing belt press is still running and trying to maneuver that through the knockout panel, it's still going to be pretty tight. And then we have to think about how we're going to demo that right belt press while everything's still going. You know, there's a large concrete pad underneath that belt press that's going to have to be demoed, and it's not necessarily going to be a surgical process. So we have to know, do we have enough room to do that? Is it really going to work? Something that's kind of different that we've also thought about is the weather and the fact that this is all going to be constructed during the winter. So if we have a big hole in the wall and we're trying to get things out and get the new screw presses in, how are we going to keep the building warm and really prevent things from potentially freezing? So these are really just things to think about that are time consuming and complicated, but they're important. And this is where that work in the procurement really comes in because we already know the layout, we already know the equipment. So now we don't have to start from scratch when we're beginning the design process.
Thanks, Maddie. All right, so what will this system look like? Since we're really just in design for the project, we wanted to show you a couple pictures of projects that we've done. This is the Biosolids dewatering room from Highland, Illinois. The layout is nice and clean. The entire dewatering operation is automated. You can basically see the FKC belt filter press here and then the flock tank over on the side. The biosolids are pumped at Highland with a double disc pump. The polymer emulsion, polymer tank over here, is added to the process in the flock tank, and so it's allowed to activate before it goes into the sludge. Then the dewatered biosolids are fed by a screw conveyor to either a truck loading bay or the dry sludge storage. Another example of one of these processes, this is in Springfield, Illinois. We have two of the incline belt filter presses, the Hubers here, but we did a layout on the conveyance that was exactly the picture that the City of Moline had in mind for what they wanted, because they too had a truck loading bay that had been built as part of a prior expansion, but had never been able to quite get that system to work. So when they toured the Springfield plant, they looked at this and said, wow, that's exactly what we want. So at least when we went into the study, we had a very clear picture of what the client anticipated wanting. So down here is the screw conveyor leaving the presses. It comes out into the truck bay. It inclines, comes up, goes over, drops back down to another conveyor, and then this conveyor has a series of different chutes that the biosolids can drop out of. Each chute has an ultrasonic level sensor, so it can sense when the pile gets to a certain height, the chute knife gate will close and it'll open over here and start filling the truck in a different location. At Springfield, they land apply their biosolids, so this is actually a bioapplication truck. The other option is that it can go out into the dry sludge storage area, and we have an exact duplicate of this system where it can drop in numerous piles, because this system in Springfield is also like the Moline ones anticipated. It's completely automated. So it can run slowly overnight and it just fills up the truck. The next morning they come in and they can actually go out, clean out the truck, bring it back and start the process all over again, which is the way it's intended to work at Moline as well. But we also have the option, as we showed, of a fail-proof of dumping it outside. So this is what that would look like. This is a typical municipal biosolid, so it's a little bit wetter than what we would have, but it still stays in a pile and then you can come back and you can handle it later. But it's like it's the third redundancy. You know, if this fails, that fails, then we can still go over here and do it outside. So just to give you a picture of what the system will look like. Conclusions, every method of biosolid dewatering does have its pros and cons, but determining the key decision factors for the end user is the most important step in the study. And that's why the City of Moline chose what they chose with the screw press, always include an evaluation of the total cost of operation of the system, because, for instance, the centrifuge was more costly because it took more polymer and the maintenance had to be done by an outside entity, versus the screw press that it spins so slowly that the maintenance is less and they can do it on their own and the polymer usage is less. Make sure you address if existing staff can perform that maintenance and include that in your cost savings. Some communities have the ability and the staff to do that, while others have to have everything farmed out. How important is complete redundancy? So in this case, it was a driving factor to have redundancy throughout the process, and both for constructability and for end use. Some folks just have one screw press and they will just store the biosolids if something happens to that press while they're getting it worked on. So understand where those requirements are and understanding those expectations of the end user. Also, always look at reusing any infrastructure that you can that's available, because that's a way to lower the overall construction cost and continue to get value out of that existing structure. We're making very few changes and using the existing building without a problem. The main issue we have is the demo of those existing containment basins. Lastly, there are a lot of ways that you can get a project completed. Evaluate the important constraints and determine how those line up with what your owner client goals are. In this case, the procurement bid build was the best choice, but that may not be the same for everyone. When using this model of the screw press, the owner can get all concerns met since the engineer worked directly with the chosen manufacturer to work out the details. The difference is in the procurement, when we do a typical design bid build, we're kind of designing around a manufacturer, but we're then allowing competitors to come in. So there's always going to be changes to the final design, whereas in this case, we are literally designing from the shop drawing of the piece of equipment that's going to be there and installed. So we can get down to every connection, the electrical is exactly as it's going to be, all of the pieces and parts are there. So when we put this out to bid, the contractor's seeing in that bidding document exactly what they're going to be installing, versus having some variability with different manufacturers getting the bid after that time. Sequence of construction, it's an engineer's either, puzzle to put together, which they love or they don't love. We kind of enjoy it because it's a critical factor, especially in these retrofits. And experience in complex construction projects is really an asset. And having done it several times before, the last thing I want to add is communication. obviously throughout the whole process, maintaining that open communication with our client and then with our manufacturers and all parties, and even getting those folks together in the same room so that everybody has the same picture when it's all finally done. And then we can make sure we have the product that not just meets the client's expectations, but hopefully exceeds those expectations. So that is putting the squeeze on biosolids. I would like to thank you for being here, and also thank the City of Moline for working with CNT on this project. Special thanks to Tony, Greg, and Justin. Those are the folks with the city that we worked with. And just in case you really wanted to know what the people that have been talking look like, I'm Christy, and this is Maddie, and I wanted to just say this is Maddie's first time ever doing a presentation, and I think she did a fantastic job.
I totally agree. I think you guys both brought great energy to the presentation. Thank you very much for that. It was well thought out, extremely informative. So well done there. One of the things we'll let, if you have questions, please put them in the chat, and Brad will monitor that. But I wanted to know if you could expand a little bit. I'm very intrigued with the procurement bid build. A lot of clients oftentimes don't want those alternative delivery methods. I think, can you expand a little bit on how the process of, is that something that they had brought to you, or what was the process of you bringing that to them? And
well, we brought it to them because actually we had just done the exact same thing with another client, the Christian County Water Reclamation District in Taylorville, Illinois. And part of it was they were working on a cash basis. They had the money to do the project, so you didn't have to worry about getting any state or federal funds, which that will mess that whole process up. And so we said, hey, you know what, we did this, and this is how it worked. And it was the exact same reason. They wanted the project done over X time frame. They wanted it done in 6 months. Well, you can't do a design bid build in 6 months. You can't even get the equipment. It's just showing up to the site after that. So we had done the same process, and we walked the City of Moline through how it went, how construction was, what are the pros and what are the cons. Really, the biggest con to it is the fact that the owner is taking on some additional responsibility because they're buying it, they're handling the warranty, and if all goes well, it arrives while the contractor's there. The contractor can then offload it and basically install it right into its location, which is actually what happened at Taylorville. And it just made it a very smooth transition through the whole process. It's just really killer when you have a project that, if you look back, let me go back to the site plan. So there's really not that much work that's going on. You're demoing, and then you're coming back with these presses. But you'd have to have almost a year schedule if you were doing a design bid build, just because by the time it's let, the contractor issues their PO, we get the shop drawing goes back, and then you have 6 or 7 months before the equipment can get there. We can cut that time down so that the equipment's being built while we're actually doing the design.
are you helping if it's new to the client as far as the procuring the equipment? Are you assisting them as well in communication on how to walk through that and work with them on that piece as well?
Absolutely. The City of Moline's been great to work with. We've had so many meetings with them to go over all of the, I would say, the intimate details of trying to walk through that process and to make sure that everything's going along as it was. Especially on the wastewater and water treatment side, like every piece of equipment is specialty made per the application it's going into. So trying to get 4 different manufacturers to line up, we basically put together a performance spec with all the pieces and parts that fit that manufacturer, and then allowed them to bid each of their independent systems against the other manufacturer without tying their hands and not giving them the flexibility to do what they needed to do with their own components. And then we did do an evaluation after the procurement documents were received to make sure that everyone had bid to the same level and that the owner was getting, as Maddie said one day when we were doing this, apples to apples instead of apples to pears, and make sure that it went along that way.
Being a young engineer, Maddie, were there any lessons learned for you or eye-opening going through this process that kind of just stood back and said, wow, that's
Yeah, I mean, I've been with CMT for about 8 months now, so this is kind of one of the first projects that I've been involved with at the very start. So really, it's just a matter of taking in as much as you can and trying to understand even the mechanical aspects of this project and just trying to understand everything that is going into the design so I can use that, you know, with future projects as I gain more experience.
yeah, that's fantastic. Well, good. And you have probably a good mentor there in Christy, so it sounds like made a great team. So, are there any other questions from our audience?
It doesn't look like it, Dad, but I just want to echo what you said about how great the presentation was, and it was really interesting to hear about such a critical part of Moline's infrastructure that hopefully will keep them doing well going into the future. And on behalf of the City of Moline, thank you for your work on this project.
Absolutely, we appreciate the opportunity to be here.
This is recorded, as we said earlier, and if you guys have their bios, we'll get their emails out to them. So if the audience has additional questions outside of this, please feel free to email them. But thank you again, Maddie. Great job, Christy. Appreciate your guys' time today. We're going to take a break for lunch, and we'll kick off our next session here right at, where are we at? Right at 12:30. So thank you, everyone. We'll give you a little bit of a break, and we'll see you back at 12:30. Thanks, Christy. Thanks, Maddie.
Thank you. Bye-bye.
Thank you.